So this is just called an introduction to solving trigonometric equations because it's going to be the most simple ones that we can look at. But whatever we do here, we're going to use when we get to the more complex ones as well. We'll just have to do some other work first. This one, solve the given equation for the stated domain. So the equation is sine theta equals root 3 over 2, and the domain is that theta is between 0 and 2 pi. What's this question asking us for? What's it asking us to find? The angle, right. The value of theta. So it's saying what angle or angles have a sine of root 3 over 2? What angles between 0 and 2 pi have a sine of root 3 over 2? So it's really what we were doing yesterday with finding the exact values of trig ratios, but it's working backwards. Yesterday you were given an angle and you had to find the trig ratio. Now you're given the trig ratio and you have to find the angle. So it's very similar. We're still going to use special triangles. We just have to think which triangle has a root 3 and a 2 in it. And that's this one. 1, 2, root 3, pi over 3, pi over 6. We need to look at that triangle and say, which of these two angles, these are our choices, have a sine of root 3 over 2? Which means an opposite side of root 3 and a hypotenuse of 2. Well, the hypotenuse is 2, so that's fine. But which angle is opposite the side root 3? Pi over 3, right. So what that means is, for this equation, the reference angle is pi over 3. So now if we want to figure out what the actual angle is, we consider the cast rule. And what we were given was sine theta equals root 3 over 2, which is positive. So we need to look at where is sine positive. Quadrant 1 and 2. So in here and in here, 1 and 2. Those two angles that have a reference angle of pi over 3 are going to be pi over 3 and 2 pi over 3. So the answer then is that theta equals pi over 3 and 2 pi over 3. There are other angles that have a sine of root 3 over 2, right? Like if I went all the way around the circle again, so there was pi over 3, but there would also be 7 pi over 3, and then another 2 pi after that, and another 2 pi after that, and there's negative angles as well. But it's only asking us for this one in the domain from 0 to 2 pi. That's why I only have to look at one full circle. If the domain was different, we might have to look at more of them. And also, sometimes you're asked for a general solution. So what are all of the angles that have a sine of root 3 over 2? All we need to do for the general solution, take those two that we found, and I'm going to list them one on top of each other, because then I'm going to say plus 2 pi n. And I will also want to say that, I'll put it down here, n is an integer. That's kind of a lot of sort of math jargon there, but what it means is theta is pi over 3 and then plus any number of 2 pi's. So you could add 2 pi once and get another angle, or you could add it twice and get another angle, or 3 times, or 4 times, or 12 times, or negative 8 times. As long as n is an integer, you're adding a full rotation. And then the same thing with 2 pi over 3. If you add 2 pi to that, you'll get another solution. If you add 2 times 2 pi to that, you'll get another one, or 3 times 2 pi's. So it's really just adding a whole revolution. Here's another one. Cosine theta equals 1/2, also between 0 and 2 pi. So we need to decide which reference angle we're going to use. And it's the one that has a hypotenuse of 2 and a side length of 1 because cosine is adjacent over hypotenuse. So let's go, same special triangle, right? 1, 2, root 3, pi over 3, pi over 6. So it's pi over 3, right? Adjacent is 1, hypotenuse is 2. So we're looking at a reference angle of pi over 3. Is the reference angle actually one of the solutions? Yes, because cosine is positive, and cosine is positive in the first quadrant and the fourth quadrant. So theta is pi over 3, and what's that other one? 5 pi over 3. It's the angle in quadrant 4 that has a reference angle of pi over 3, so it's 5 pi over 3. Okay, here's one more. Tangent theta equals 0. And this one also has a different domain. Negative pi to pi. Just because I thought I'd like to make it a little bit trickier. It's kind of trickier anyway, but tangent is equal to 0. None of the special triangles have zeros on them. Where do we find zeros? On the axes, right. So if we look at these points here on the axes, this has coordinates of 1, 0, because we're talking on the unit circle, right? This is 0, 1, negative 1, 0, 0, negative 1. Those would be the points on the axes that are on the unit circle. And we know that those points take the form cosine theta, sine theta, and one more thing that we need to know, that tangent, we talked about this just really briefly the other day, tangent is sine over cosine. So we need to look at which of these, when you take the y value divided by the x value, will give you 0. Zero. 0 and pi. And 2 pi, maybe, right? But that's not in the domain that we're looking for. So if we're just looking for a reference angle, we could say there's 0 and pi. Then we need to figure out if those are the angles that we're looking for or not. So now we need to consider the domain. But is the 0 and pi okay? Yeah. It's here at 0 because sine over cosine is 0 over 1 there, which is equal to 0. That's what we're looking for. And at pi, it's 0 divided by negative 1, which is also 0. So those are the 2 points.
And the 5, the other two don't even exist.
The other two, the tangent's undefined because it's 1 divided by 0, negative 1 divided by 0. So it's at 0 and pi, but we want the values of theta that are between negative pi and pi. So, what's that? Negative pi is if you start at the x-axis and go clockwise 1/2 circle, right? So negative pi actually is one of the answers, right?
How would you write that as tan negative pi or negative tan pi?
You're just going to say theta equals negative pi. Is how you're going to write it. So negative pi to pi is actually this. Negative pi is here. And then if you go all the way around to pi, it's there. That's that domain negative pi to pi. So when we look in there, we have negative pi. We also have 0 is in that domain. And pi. Because negative pi and pi are both included, right? Less than or equal to in the domain. So that one has 3 solutions.